we talked about degrees and radians. Now, who can remember what is 180 degrees? What is that equivalent to? Okay, so that's pi. Technically, you can say radians. It has like a little c, but hardly anybody ever uses that. As soon as you just see pi there, or really, really small, we know that we're in radians, or we would even put 1.2 radians. So we know that, okay? I hope that you also get that the whole graph, the sine graph, comes from going around a circle, our unit circle. And so does our cosine graph. It's all related to periodic phenomena, so waves coming and going, the cycle of temperature, music, sound waves. This is all trigonometry. Oh, just glorious stuff. Anyway, it all links together. So we did our little conversion from degrees to radians, and that was, where'd it go? That was exercise 5A. Pretty simple, okay? You had to finish off your worksheets, which will come and have a chat. Was there any problem with this? Now, where I would like to go, bang, straight into the unit circle, they want to sort of link the numerical trig with the radians a little bit, but So you're going to be asked in a momentito to find, and it will only be a momentito, to find arc lengths and areas of sectors, okay? So when we have a nice circle, they're going to ask you to maybe find part of that circle, right? So this arc length, they might say, please find that. Yeah? And they might then ask you, oh, what colour will that be? I can live with that. They might ask you to then also find the inside area. And what makes this Year 11 methods work rather than Year 8 measurement work? The fact that they're going to ask you to use radians instead of degrees. No biggie, I don't think. We'll be doing all of that, don't worry. I've got sheets for you. So, if we have a look, our good old friend pi r squared, we're happy, we remember that from area of a whole circle, and then we would normally say theta out of 360. Do you remember that? Why 360? Everybody's silent, and it's silence in the room. 360 degrees in a circle. So all we're doing is changing that 360 to 2 pi, because we know pi, 180 degrees, is the same biseau, yes? That allows us to cancel. Look, we've got a pi upstairs, we've got a pi downstairs, but it's all come from the same area formula. So that's how we now have this little formula for area of a sector. So if I've got this being, let's call that, get out. If I now call this is our theta, okay? Our area, what did we just say that was? Theta out of 2 pi times pi r squared. They cancel, so our formula is theta on 2 times r squared, or a half theta r squared. You realise they're all the same, right? Can I write that another way? All of those are the same. So don't get bogged down. Do you have to write all 3 of them down? Please don't. Write the one that you go, I like that. But you just make sure that you know they are all the same. Let me just double check that they've done it like that. You could do it any way you want. Is that all right? So choose one. Yep. No. It's all, that's bad writing. Why is this bad? Look at that. What does that look like? Yes. Poor form, Mac. Poor form. No, got to change that. I mean, I'd like to think everyone knows by now timesing by half is the same as dividing by 2. All the same. Choose one. If you want to write them all down, go for it. But I'll just do it to the side again. So circumference of a whole circle is 2 pi r. So again, if we're dealing with a fraction, like an arc, just part of the circle, then again, we times it by the fraction of the circle that we have. When we're in year 8, year 9, year 10, we say it's theta over 360, but now you're big people and we want to scare others who come in and go, oh, what are they doing working with pi? Wowza. So instead of writing 360, we write 2 pi, and oh my goodness, look at that. The 2 pi upstairs, the 2 pi downstairs, and that's why our arc length is going to be radius times theta, or theta times radius. I bet they'll have theta times radius in the book, but anyway. So this oh, how sad. Arc length. That's my You want to see my J? My Z. Y. B. No? I'm going to bring my history book in to show you. It's all in cursive. B. Page, what did I say? 124. Find the arc length of each sector. Your only degree of difficulty here is reading the question and choosing the right formula. So the arc length, we're looking at that one there. Right? You write your formula, Sask, L. Was it r times theta or theta times r? That's all good. What's my radius? Well, that was a stupid question, wasn't it? 7. Bit of a letdown. Same with 4. Would you draw the diagram? If you think this is hard, maybe draw 1 if you needed to. But no, if you've got it all labelled, you've got today's date. Yeah, I personally, no. But if you think, it doesn't sit well with me, maybe draw 1 diagram and working underneath, and that's it. I'm not even going to do B. Huzzah. Can I ask you, instead of, if I now chuck this up, oops, that's not nice. If I chuck this up, what would you do? You could either change 100 to radians, or you would then be using the degree one, right? They're not going to. We're now working in radians, so we use our, I just go into area, sorry. saw the look. Does that make sense? If I was wanting the arc length, then yes, I would go arc length is 2 pi r times theta over 360. So if it gives you degrees, like if you're helping your little brother or sister, please don't show them the radian stuff. You'd be doing this. But as soon as we see radians, we go for our formulas. All right. So we want to move it along because we can't spend way too much on this stuff because it's... So A and C, you're going to do question 2. You're now doing the area, AC. Let's see. We'll do 1, 2... Shall we do 5? We'll do 4 and 5. 1, 2, 4 and 5 to start with. So hello those playing at home. We are on page 124-25 and we're doing exercise 5B, and these are the questions that we're about to do in 10 minutes. 10 minutes. So write those down because the video is about to move on. Pause it then and go backwards. Here we go. Okay. Oops, I minimized something then. So these are the questions that we have to do of 5B. Okay? So write those down. Pause the video. And question 4 and 5, similar. So you do them the exact same way as in the process. So find in radians the angle. We're needing to find an angle this time. And what information have they given you? As soon as they say arc length, I would expect you go, arc length is r times theta. And then what do? It's all about the sub. All right? Do we have the arc length? Oui. Yes, we do. It's 2.95. What else do we have? We've got the radius. I mean, come on. Can we get theta by itself? Yeah, man. Shh. Hey, you're silently doing this, or you're listening, but you use no option to talk. Hello. We are not talking at the moment. B, pretty much the same, except for what? You don't have the arc length. What do you have? Right. So instead of writing down the arc length formula, you will write down the area formula. What was it again? I know, because you said a half. I deliberately wrote the other. I know. Mean, aren't I? We sub. So 30. And we can get it. Oui? I don't want to burst your bubble. 5's pretty much the same, except they give you a diagram. Diagram here, we're going to say that this is 0 degrees. Well, we better put that there. This up here is 90 degrees. What would this one be? 180. And down here, 270. And then back up here, it's back to 0 degrees, which is also 360. Do we agree with that? Thank you. Right. Now, these are all in even divisions. So what degree would this be? What would this one be? And so on and so forth. You can get that, correct? Yes? I want you now to go back and we're going to do the radians as well, which is one of the things we were finishing from 5A. So that's 0 and 360 is 2 pi. How do we convert 30 degrees to radians? So you can look up, that's what you did yesterday. So we're going to go 30 times pi over 180. They cancel. 3 into 18 is 6. So this is pi on 6. Yeah? Does that make sense? You are going to do that for all of these. It should not take long. We do not do the coordinates. We'll fill that in on Monday or whenever we see each other again. Is that okay? So finish 5B, those questions, and complete the degrees and the radians going up in lots of 30.